In this video, we'll prove that adding subspaces is associative. Feel free to give it a shot and keep watching to see the solution. Where else have we seen associativity with addition in linear algebra? We've seen it with vectors in the same vector space. So maybe this can help us solve the problem. How did we define subspace addition? Okay, this is our definition. Okay, what's the goal again? The goal is to go from here to here. How do we get there? Well, since we're adding a lot of subspaces, we'll probably need to use the definition. Okay, let's go ahead and do that. How can we use the definition to help us expand the left-hand side of the equation? Well, since this is a subspace and this is a subspace, we can plug u1 plus u2 in for u and u3 for w with the definition. Okay, let's go ahead and plug it in. So we've got, I'm going to copy the left-hand side of the equation real quick. Okay, so we're plugging this in for u and this in for w. What does the right-hand side of the definition turn into? Okay, so this is going to turn into u1 plus u2 and what's this going to turn into? Okay, so lowercase u1 plus lowercase u2 plus lowercase u3. Okay, what comes next? Such that, where does this belong? Okay, so such that u1 plus u2 is a vector belonging to this subspace. Okay, what else? Where does lowercase u3 belong? This subspace. Okay, so we know that this is equal to this. Because of what? Because of the definition. So I'm going to write by definition over here. What's our goal again? Our goal is to go from here to here. We already have this part of the equation. Which part do we not have? We don't have this part yet. So we should try to get it. We should try to turn this into what? We should try to turn this into this. Okay, we're going to do a little bit of wishful thinking here, and we're going to pretend that we are able to change this part to u1 plus parenthesis vector u2 plus vector u3. Okay. What would go after the colon? What subspace would this belong to? It would belong to subspace u1. And what subspace would this vector belong to? Subspace u2 plus u3. Okay, but is this really equal to this? Okay, well first, is this equal to this? Well, yes. How come? Because these vectors belong to the same vector space. So associativity with addition holds. Okay, but we need a way to bridge this and this. How do we do that? By the way, I think we're close to finishing the proof because we've got subspace U1 by itself and this subspace by itself. We just need to find the bridge. In fact, we can go ahead and say that this is equal to this. Okay, and we said that this is equal to this because of what? Vector addition is associative. Okay, but we still need to bridge this. There's still some vector space addition in this line, so maybe we can reuse the definition again. And let's go ahead and do that. If we were to apply this definition onto here, what would this turn into? Okay. And okay, I'll just go ahead and copy this. This doesn't change. Okay, but what does this turn into if we were to plug U1 and U2 into the definition? This part would turn into u1, vector u1 belongs to subspace, vector subspace u1, and then vector u2 belongs to subspace u2, and then this doesn't change because we didn't touch it. Okay, and why is this equal to this again? We use the definition again. Okay, so now the question is, can we go from here to here? Are these two equal? Well, what's different? We combined u2 and u3, vectors u2 and u3, as well as vector spaces u2 and u3. Can we do that? Yes, we can if we were to plug it into the definition again. If we were to plug vector subspaces u2, u3 into the equation again, we'd be able to transition from here to here. Okay, and to complete the proof, why is this equal to this? Well, if I were to plug this into the definition again, I'd end up with this. By definition,